Hello and welcome back to another video. Here we are going to discuss another past year paper from October-November 2020, and this is Probability and Statistics 1, that is S1, and the code is 9709 and component is 52. So let's start with the question number 1. And here is question number 1. A fair six-sided die with faces marked 1, 2, 3, 4, 5, 6 is thrown repeatedly until a 4 is obtained. It means it's a geometric series, geometric progression. First part is find the probability that obtaining a 4 requires fewer than 6 throws. So we are only focusing on the first success. So we'll take x as the number of throws required to get the first success. Then it is geometric progression and geometric distribution, and it is the probability, success probability means success probability of getting 4 is going to be 1 by 6. So it is 1 by 6 here, and since p is 1 by 6, q would be 5 over 6. Now the question, the probability, the required probability, will write probability of x. 4 to get 4 fewer than 6 means x should be less than 6. It means it is going to be 1 minus probability of x greater than 5, we can say. Means more than 5 is required. We could have written it like more than or equal to 6, but that is same as more than 5, because in the geometric distribution we have this probability as q raised to the power 5. So it becomes 1 minus 5 over 6 to the power 5. And now we will calculate this from calculator. 5 over 6 to the power 5, it is coming 1 minus 0.401877, and also I'll write 8, and then 1 minus this thing is going to be 0.5981, so 598 till 3 significant figure. This is the probability that it requires fewer than 6 throws to get the first 4. I hope it was of some help. Let's do the second part. On another occasion, the die is thrown 10 times, so n is 10. Find the probability that a 4 is obtained at least 3 times. So we are going to make it as, you can think of it as a binomial, because all the trials are independent of each other, and the success probability would be remain same, like 1 by 6 for all. So we can take it as binomial, and x is going to be the number of number of success, we can say number of times 4 occurs. So it is binomial, and bn is 10 here, and p is of course 1 by 6, because to get the 4 in a die is going to be 1 by 6. So the question become probability of at least 3, so x should be greater than or equal to 3, and we will not go till 3 to 10. So what we'll do, we'll subtract this from this probability of x is less than or equal to 2, means 1 minus probability of x is equal to 0, 1, 2, means 1 minus, it is 10 c0, 1 by 6 to the power 0, and 5 by 6 to the power 10, plus 10 c1, 1 over 6 to the power 1, and 5 over 6 to the power 9, and the last 10 c2, 1 over 6 to the power 2, and 5 over 6 to the power 8. Now we will write these values, not simplifying, of course. Without simplifying, we will write these values, and this is going to be, so the first value 10c0 is of course 1, so this value will calculate, and it is 0.16150 and all, so I'll write till 4 decimal place, plus this value to the power 9 and 1, and we'll multiply by 10c1, that is of course 10, So the answer is 0.3230 and 1 and all, plus 10c2 is 45 and 1 over 6 to the power 2 and a to the power 8. This value is 0.29071 and all. Now we will add them and subtract it from this total value, plus 0.3230 plus 1.1615. So the total is 0.7752, and once we'll subtract it from 1, final answer is 0.2247, so 225 till 3 significant figure. This is the answer. This is the probability that at least 3 times 4 will occur. Now we have second question. A bag contains 5 red balls, 3 blue balls, 5 red and 3 blue balls. Sadie takes 3 balls at random from the bag without replacement. The random variable x represents the number of red balls that she takes. Show that the probability that Sadie takes exactly 1 red ball is 15 over 56. So x is going to be the number of red balls, and if she is going to take 3 balls, so in that we have probability of x is equal to 1 we need to find. Then first of all 3c, I will focus on the red ball, and of course the probability of getting red ball is 5 over 8 from here, and getting blue ball is 3 by 8 if it is not being chosen. Now 3c2 will 3c1 because one time we require, and first ball is red, so first ball is red, probability is 5 by 8. Then without replacement means second one, now the second denominator would be 7, so second should be blue of course, so 3 by 7, and the next is also blue, so now there are only 2 blue balls and total number of balls are 6. So we'll solve it. 3c1 is 3 into 5 into this, so 3 2s are 2 times this, and then we are left with 3 into 5 upon 8 into 7, that is 15 over 56, and hence proved. So this is kind of binomial, but whenever it is like without replacement we have to keep on decreasing the total number of balls and the number of balls if it is being chosen. I hope it is clear. Let's do the B question, the B part of this. B part, draw up the here is the B part. Draw up the probability distribution table for x. We know that x is the number of red balls of 3 selection, 3 balls, so it can take 0 values, no red ball, 1 red ball, 2 red balls, and at most 3 red balls. 0 red balls means all of them were blue, and 1 red ball we have already done, 1 red and the 2 blue. Of course there are different selections, different combinations like BRB and BBR and all. For that we have chosen 3C1. Similarly here 2 red balls, so we are writing 2 red balls and 1 blue ball, and here all of them are red. So we will take 3C1 here for this combination of R, and 3C2 in this case, and this is 3C3, that is of course 1. So the probabilities for x is equal to 0 is going to be all blue, so it is there were three blue balls, 3 by 8 into 2 by 7 into 1 by 6, which is 6 cancel, 1 by 56. And for probability of x is equal to 1, we have already calculated in the previous part, that is 15 over 56. And for probability of x is equal to 2, it is going to be 3c2, because the combination of these 3c2 with first red is 5 over 8, second red means 4 over 7, and third one is blue, there are 3 blue, so 3 over 6. So it becomes 5, and we can cancel this 2 and then 2, it become 10 times 56, and 3c2 is, it will be 3 into 10, 30 over 56. And the last one, when it is all 3, so all red, probability of x is equal to 3, it would be all 3, that is 3c3 1, and then 5 over 8, then 4 over 8, 4 over 7, and then last one is 3 over 6. 3 2s are here, 2 2s are, so it become 10 over 56. So let's draw the table. So here we'll write x values. X is equal to, x means 0 1 2, and the last one I forgot to make it, let's say it is 3 here. Then the probability of x is equal to x. For 0 it was 1 over 56. For 1 it was given from the previous part 15 over 56. And for 2 it is 30 over 56. And for 3 it is 10 over 56. Now in order to just check whether it is correct or not, we have to add them all and to check whether it is 1 or not. So 1 plus 15 16 plus 30 46 plus 10 56, so it is correct. That's the distribution table for x. And here's the C part. Given that ex, expectation of x, is 15 over 8, find the variance of x. So I'll bring the distribution table here so that we can calculate it. So here's the distribution table. Now we can see that expectation is 0 into this, 1 into this, 2 into this, and 3 into this. So what we are going to calculate, we are going to calculate variance of x. And variance of x is expectation of x square minus square of expectation of x. So expectation of x square means 0 square into its corresponding probability plus 1 square into its corresponding probability plus 2 square into its corresponding probability plus 3 square into its corresponding probability minus the square of the expectation, that is 15 over 8 given. Otherwise also we could have calculated by this multiplying and adding them all. So now we are left with 1 over 56 here plus 0 over 56 here, because 0 into 1 is 0, and 15 over 56 plus 4 into 30 120 4 3s are 12, 120 over 56 plus 3 3s are 9, 90 over 56 minus 15 square is 225 over 8 square is 64. So we'll calculate 15 plus 20 is 135 now, 135, and 90 225, 225 over 56 minus 225 over 64. Now we'll simplify it. So numerator is same 224 and denominator 225, and 56 minus 64, and we calculate 1 over 56 minus 1 over 64, it is 1 over 448. So 225 into this is going to be 225 over this, and which is it is 445, not this. It is 8, sorry, that was and this is 0.50223. So we can leave our answer till here or till the 3 decimal places or 3 significant figure. That's the variance of x. I hope it is clear. Let's do the next question. Here's the third question. Pia runs 2 km every day and her times in minutes are normally distributed with mean 10.1 and standard deviation 1.3. So mu is 10.1 and sigma is 1.3. Now the first part is find the probability that on a randomly chosen day Pia takes longer than 11.3 minutes to run 2 km. So we can take x as the time taken by her, and if it is normally distributed, so the parameters are 10.1 and 1.3 square because we require variance here, and standard deviation is 1.3. So the probability we want to find x to be greater than 11.3, and in the standard normal distribution with z it is going to be greater than 11.3 minus mu, that is 10.1 over sigma is 1.3. So we will calculate now this value 11.3 minus 10.1, so it become 1.2. So it's probability of z greater than 1.2 over 1.3, and which is going to be 0. So probability of z greater than 0.92307, and also right till here, and we can see this is a positive quantity, so this value would be lying somewhere here, and we require z greater than that. It means we want to find this area, and this area is 1 minus phi of z if this is z. So it would be 1 minus phi of 0.923. Now we will calculate this phi of 0.923 from the distribution table, and this value from the normal distribution table is 0.822, and if we'll subtract from 1, so 0 minus 2 8, 9 minus 2 7, and then 9 minus 2 1, it is 0.178. I hope it is clear. Let's do the next question. And here's the B part. On 75% of days, Pia takes longer than t minutes to run 2 km. Find the value of t. 75% here and longer than t minutes. So if we draw the diagram distribution graph, we'll see the more than then, and it is 75%, so t has to be somewhere here, then only we can have this as 75%. So we will write this as, because in the previous part we know, so x is normally distributed with parameters mu 10.1 and another is 1.3 square, that is sigma square. So the probability of t, that is x greater than t, is 75%, 0.75, and if we'll convert it into the standard normal distribution, we'll get z greater than t minus mu 10.1 upon sigma 1.3. it is going to be 0.75 here, and the probability of this is same as the probability of z less than t minus 10.1 over 1.3, and this time we will write this as 0.75, but the phi of z, that is t minus 10.1 over 1.3, we'll get it as by phi inverse of this value 0.75, but since this t is towards the left hand side of mu, it means it is going to be negative. So let's calculate this value from the distribution table. It is minus 0.75 0.674. So t become 1.3 into minus 0.674 plus 10.1. So we will calculate this value now. 1.3 minus 1.3 into 0.674 plus 10.1. So total is going to be 9.223. So 9.22, this is the total minutes. So t is 9.22 minutes. That is the value of B, T. Now here's the C part. On how many days in a period of 90 days, how many means expectation, 90 days period, would you expect peer to take between 8.9 and 11.3 minutes to run? Means again we are going to do the expectation and we have the number of days to find. So 90 into the probability of this x to be in between 8.9 and 11.3. So we will calculate this by the formula, that is 90 into p into standard normal distribution form, 8.9 minus mu 10.1 upon standard deviation 1.3 less than 11.3 minus mu, that is 10.1 over 1.3. So it becomes 90 into the probability of this and 8.9 minus 10.1 and then divide by 1.3. This value is minus 0.923, which we have already got from the first word, and then 11.3 minus 10.1 divide by 1.3. This value is again the same but with the positive sign, 0.923. And hence if you see from the diagram, we'll get it easily. This value is minus 0.923 and the same with the positive value 0.923, and we want this probability, and this is going to be phi of 0.923 minus phi of minus 0.923, and this minus would be 1 minus phi of this, so it is 90 times 2 times phi of 0.923 minus 1, because we know that phi of minus 0.923 is same as 1 minus phi of 0.923, so it would be minus minus plus and 2 times phi of this, and we know it is going to be this value from the distribution table, 0.822 minus 1, which is 90 into 2 into 0.822 minus 1. This total value is 57.96. So till 3 significant figure it is approximately 6. Since it is not completely 58 days and we are talking about the number of days, so it will take the complete days. Complete days is going to be 57 days and plus 0.96, so the final answer will write till 57 days. We don't give the we don't write it as 58 days here, we'll write 57 days. And that's it for this video, so we'll see in the next video with the next few questions of this paper. Till then, thank you so much.